So let's see another problem in classical mechanics. So a solid homogeneous sphere of mass m rotating on top of another fixed sphere is slightly displaced and begins to roll down. Let B be the radius of the fixed sphere and A radius of the other sphere. Find the angular velocity of the sphere at any instant before having that contact, that is before leaving the contact. So this is the possible diagram according to the question. So what they have said is a solid homogeneous sphere of mass m rotating on top of another fixed sphere. So this is a fixed sphere and this is another sphere and it is of solid sphere and it is of homogeneous. That means there is uniform distribution of mass and this sphere is of mass m and it is said that it is rotating on top of another sphere. So this sphere is rotating on this sphere. Rotating on top of this sphere is slightly displaced and begins to roll down. So actually this sphere should have been here. So it would have balanced, but slightly it is slightly just displaced aside. So then what happens? This sphere would start rolling and begins to roll down. And let B be the radius of fixed sphere and A radius of another sphere. So actually B is taken as the radius of fixed sphere, but here this is the fixed sphere. So it's nothing wrong. So actually here we are in the diagram it is taken as fixed sphere radius is A and this sphere radius is B. So the sphere in this it is considered as, so this is the fixed sphere and the radius of this sphere is A and the radius of the smaller sphere which is rolling on this bigger sphere is small b. Find the angular velocity of the sphere at any instant before having contact, that is before leaving contact. So actually if the sphere was here and we have displaced it to this side, so it just gets disturbed and it just keep on rolling because of gravitational force and finally it leaves the contact here. So it moves like this, it rolls down and finally it leaves the contact, falls down. So what they're asking is find the angular velocity at, we need to find at any instant what could be the angular velocity before the sphere loses the contact. So that is the problem. So now coming to the solution of this problem. So let phi be the angle rotated by the upper sphere and theta angle made by the line joining the center with vertical. So here it is given that phi is the angle rotated by the upper sphere. So this is the upper sphere. So when it is placed and it is slightly displaced, it would roll. The sphere would roll. So this sphere has rolled down phi angle. So initially the sphere would have been here. So at this point it has not rolled anything. So after slight displacement it would just keep on rolling. So it would move like this and it reaches to this point. So it keeps on rolling and keeps on moving from this point. So as the sphere rolls from here, keeps rolling, so it just moves like this in so the point here which is in contact here, that point would move up. So that point would have moved to this angle phi. So that is the thing here it is mentioned. So as it rolls down, so it moves, this point would move like this. So as it rolls down, it moves forward. That means it moves in this manner as the sphere rolls. But it is not standing still, but it is rolling. Because of rolling, it travels from this point to this point. So by the time the sphere has traveled from this point to this point because of rolling, this point would have rolled to this angle phi. This is the angle phi rotated by this point from here to like this. So here because of rolling of this sphere, it moves from this point to this point. So here rolling is also there. Because of that rolling, translation motion is also there because it has shifted its position from here to here. So this point has rolled to phi angle per sphere, and theta angle made by the line joining the center with vertical. So this is the vertical and theta. So this is the line joining the center of the sphere to the center of the sphere. So center of mass point of the sphere is taken as, so there are many points on the sphere. So the reference point we used to take is center of mass point of the sphere. So if we draw a line joining this center of mass point of this sphere and this sphere, so this is that line. So this line makes an angle theta with the vertical. So that is mentioned here. So here phi is the angle rolled by this sphere, the process of rolling down, that is when the point of contact shift moves in this manner because of rolling, and this is the angle. So instead of being here, it has displaced from here to here. So the displaced angle is theta. So these two angles must not be confused. So both the displacement would happen at the same time. So when it rolls down, this point shifts to this verse. So here phi is the displacement. So here it is rolling from here to here. So angle theta, it has traveled to this much angle theta. So both the things are happening simultaneously. So here, and next thing is another equation it is given, that is a theta is equals to b phi. Phi means we know that theta is equals to L by R for a circular motion, and that is length of the arc is theta is equals to length of the arc by radius of the sphere, like that. So as there is a pure rolling motion, so how much the sphere has rolled down, so that much distance it has traveled from here to here. So this sphere in the process of rolling on the sphere, it might have rolled some particular distance, that is nothing but length of the arc. So that is nothing but L by phi. So here phi, this is the angle phi. Phi is nothing but L by R. So this is the length of the arc and this is the radius of the sphere. If we consider the smaller sphere, the case of smaller sphere, so phi is the angle. So from here to here, length of the arc is L, and L by R, radius is nothing but B. So L by B is equals to phi from this sphere. And at the same time, after as this point has rolled down, it has traveled, the center of mass point has traveled from here to here. So that is also a length of the arc. So that distance is also L, because this is a pure rolling motion. If we consider, if the sphere is just rolling on this bigger sphere but not slipping, so then we would have L, and radius of the sphere is nothing but L by A. So theta is the angle here, so overall angle from here to here. So theta is also L, length of this arc, by A. As the length as the distance traveled by the sphere in moving from here to here is same as the distance rolled down by this sphere, by this point on the sphere, are the same. Hence we are having L in the same. So finally we would have L is equals to A theta, L is equals to phi b. As both the lengths are equal, so from these two equations we would have this equation. As L is equals to A theta, L is equals to B phi. So equating those two, we would have this. So using conservation of energy, so of course, and another important point is this is also would help in calculation. So if we differentiate on both sides with respect to time, so it has A is a constant, so it can be kept aside. So theta dot, A into theta dot, and here also B has to be kept aside, so that is also a radius constant, and phi dot. So A theta dot is equals to B phi dot. If we differentiate on both sides this equation, so we will get this equation. So from this equation, if we see phi dot, so if this phi dot remains this side, and if we send theta dot to this side, so phi dot by theta dot is nothing but A by B. So A divided by B, phi dot by theta dot is nothing but A by B. And next thing is using conservation of energy. So by using law of conservation of energy, so potential energy when of the sphere when it is at this point. So when the sphere is at this point, it is having only potential energy. So as it starts rolling down, it would have both potential energy, translational kinetic energy, and rotational kinetic energy. So that one we would discuss here. So initial case mgh, the sphere this sphere was having only potential energy, and it is measured by taking the center of mass point of the sphere as the reference point. Actually ground would be taken as reference point mgh, but here we take reference point as this sphere. So in this frame of reference, in this sphere's frame of reference we are considering, so with respect to center of mass point, so here the potential energy is taken as 0 at this point, at this height. In this sphere's reference point we are taking. So now here the potential energy is 0, and center of mass point is considered with respect to uh, center of mass point. So whenever we take consider, so this is a object, bigger object. So for that bigger object we consider center of mass point. So distance of this center of mass point of this smaller sphere from this bigger sphere, so that is nothing but height. So because this is taken as reference point, that is potential energy is 0 at this point, so this is the center of mass point of the smaller sphere. So distance between them, these two, is nothing but, so this is a, as usual, the radius of the bigger sphere, and this is b, radius of the smaller sphere. So overall if we add a plus b, hence we are having mgh, potential energy at this point, potential energy of this smaller sphere at this point, that is mg a plus b, a plus b. So this is now, so potential energy at this point is equals to total energy at this point is equals to total energy at this point. So at this point the total energy, as it is not in motion, it is at rest position, it is having only potential energy, so total energy is present in the form of potential energy. But now once it has been displaced, it started rolling, and it has picked up to there. So this sphere is actually rolling, plus at the same time it is translating from this point to this point. It is changing its position from this point to this point. So because of that, what it would have is, plus it is had certain distance from this reference point. So because of that, it would have potential energy, translational kinetic energy, and that is also because of this rotating. So here because of translational motion we are getting that kinetic energy, and translational motion is also present in form of angular motion. So and as the sphere is rolling, so rotational kinetic energy. So at this point the sphere is having, at this point the sphere was having only potential energy, but at this point it is having potential energy, translational kinetic energy, and rotational kinetic energy. So these three energies are to be added. So now let's look at the formulas. So mgh, in the place of h we are having a plus b cos theta. So when the sphere was at this point, so it would be at a maximum height. When the sphere was at this point, it was at a maximum height from here to here. So a plus b. So as it is moving from here to here, the center of mass point's height from the reference point. So this is the reference point. So this is the reference point. So center of mass point's height from this reference point would change, and it would be always less than a plus b. So how to calculate this height is, so as this is angle theta, then this is also would be angle theta, because these two lines are parallel. So mg, weight acts vertically downwards, and this is reaction force. Reaction force acts normal to the point of contact. So this is the point of contact. Normal is nothing but radius. So radial is nothing but normal. So this is reaction force. This is weight of the sphere acting downwards, and as it is moving in this manner, in this downward manner, so frictional force will always oppose in this manner. So rolling frictional would act. So now as this is parallel to this, vertical is parallel to this, because gravitational force acts vertically downwards. So this, if this is theta, then this angle would also be theta. This is also theta, and we know this is the height. we need to find out at this point. So cos theta is nothing but adjacent side by hypotenuse. So adjacent side is nothing but height. Hypotenuse is nothing but a plus b. So height by a plus b. So cos theta is nothing but h by a plus b. So h is nothing but a plus b cos theta. Hence we are having mg a plus b cos theta over here because of this height. And next is half mv square. V is nothing but r omega. So here if we see, this is the point. So this point is moving like this. So it is just getting translated like this. Seems like this point is moving in circular motion with respect to this point. Hence, V is nothing but r omega. R is nothing but radius. Radius is nothing but a plus b. And omega is nothing but theta dot. So how much angle it is getting displaced? So that is how much in this much time, how much angle is, that is d theta by dt. That is nothing but angular velocity. So how much angle is it getting covered? How much angle is it getting covered in a given time? So that is nothing but angular velocity, that is theta dot. Hence we are having half m v square. V is nothing but r omega. R is nothing but a plus b whole square here, because if you consider this part. So a plus b whole square into theta dot square, angular velocity. So this is because of translational motion, and as the sphere is rolling, so it is exhibiting rotatory motion. So in that case, rotational kinetic energy, that is half I omega square. So half I omega square. So I is nothing but moment of inertia of the sphere. So for a solid sphere, moment of inertia is nothing but 2 by 5 m r square. So 2 by 5 m, or radius of the sphere is b. So 2 by 5 m b square. And omega square, here in the process of rolling down, it is this point is getting shifted to this angle, plus at the same time it is rolling on this sphere also. So rolling motion is taking place on this because of this sphere on this so this angle. So by the time this angle changes, this angle is also changing in the process of rolling. So as this sphere is rolling like this point is getting rolled like this, plus at the same time that point is getting shifted to here. So that is also should be considered if we consider the point of contact. So it is moving like this point of contact in that sphere, it is rolling, plus with respect to this sphere it is covering this theta angle. So both the things are happening simultaneously. So there is change in this angle and as well as this angle. So both the angles are getting changed. Hence in the place of omega we are having theta dot plus phi dot whole square. Because this point is rolling with on this sphere, at the same time it is rolling on this sphere also. So overall if we take, angular velocity is theta dot plus phi dot whole square. So half I omega square. Half I is nothing but 2 by 5 m b square, and omega square is nothing but theta dot plus phi dot whole square. So this is the main equation we need to consider. So from this equation we can find out, if we solve this equation, finally we can get the required answer. So finally if we see here m is common on both sides. So here also m is there, here also m is there, m. So m would get cancelled. So here m would not come. So here also, so some mistakes would be there. M would not come. Here also m won't come. Here also m won't come. So finally if you see in the answer also, it is 10g 1 minus cos theta 7 into a plus b. So g has meter per second square units, and a plus b is nothing but radius, that is meter would get cancelled. So you would have 1 by second square. So theta dot square is nothing but radians per second square. So dimensional analysis, according to the dimensional analysis also, here m won't come. Actually it has to be get cancelled in this equation. So that's a mistake. So and next is here also mg into a plus b, here also mg into a plus b, but only thing is cos theta. So let's send this term to this side. So if we send, so actually m is cancelled. So here g into a plus b, here also g into a plus b. If we take it common, g into a plus b, So what would remain is here 1. Here cos theta. So 1 minus cos theta after sending this term to this side. And here as usual half into a plus b whole square theta dot square, and here actually 2 would get cancelled, so 5 would remain, and b square would remain, m has get cancelled. So next what we have to do is take theta dot common from here. So it is all from a plus b whole square. If we take common a, we would have 1 plus b by a whole square like that. So if we have taken theta dot square common, and what we would have is 1 plus phi dot by theta dot, but phi dot by theta dot is nothing but a by b. So we would have 1 plus a by b whole square, 1 plus a by b whole square, 1 plus a by b whole square, that is nothing but if you take LCM, b plus a by b, that is a plus b by b whole square. And finally here b square would get cancelled. In the denominator also we are having b square, numerator also b square, so we would have 1 by 5 only a plus b whole square, and here theta dot square is there, here also theta dot square is there, so it has to be taken common. So finally next thing is here 1 by 2, here 1 by 5. If we take LCM, so 5 into 5 by 5 into 2 by 2, 5 plus 2, that is 7, and 5 2s are 10, that is LCM, so 7 by 10. And here already one a plus b is there, here a plus b whole square is there, so it would get cancelled, a plus b, here 1 a plus b, so 7 by 10 a plus b theta dot square g into 1 minus cos theta, and theta dot square let it be kept this side. So if we send to this side, so 10g into 1 minus cos theta by 7 into a plus b. So if we send this to that side, so 10g into 1 minus cos theta by 7 into a plus b, we send it to that side. So 10g into 1 minus cos theta by 7 into a plus b. So actually what we have to find out is angular velocity of the sphere. So this is the angular velocity of the sphere, that is theta. So how much angle it is covering in how much time, so that is nothing but theta dot square, theta dot. So if we send this square to that side, we would have square root. So theta is dot is nothing but square root of 10g into 1 minus cos theta by 7 into a plus b. So this is the angular velocity of the sphere. So this was the thing we wanted to found out. We needed to find out, this was the thing we need to find out in this problem. We have finally found out that, so angular velocity of the sphere. So that is the problem. So thank you.